Hi, so this is an example of a two-dimensional word problem you might get in grade 11 trigonometry. So I have a 10-meter flagpole on top of an office building. The angle of depression from the top of the flagpole to a point near the ground is 46 degrees. The angle of depression from the bottom of the flagpole to the same point on the ground is 43 degrees. I'm asked how tall is the building correct to one decimal place. So I've got my ground. It's not very straight. Let's do it again. There we go. I have a building. I'm trying to figure out how tall it is. There's a flagpole on top of the building. I know it's 10 meters tall, right? And I'm told that if I were to look out from the horizon, the angle of depression from the top of that flagpole to a point on the ground would be 46 degrees. So since that's 46 degrees, I can use my Z rule, and I know that this is also 46 degrees. But I'm also told that from the bottom of the flagpole to the same point on the ground, well, the angle of depression there, I'm told that this is 43 degrees. So if that's 43 degrees, that means this is 43 degrees. So I have a triangle, and I also have two right angle triangles, right? Because the angle between the building and the ground is 90 degrees. So I'm going to just focus on one of these triangles for now. I'm just going to focus on the triangle that was created by my 10-meter flagpole. And if this one's 46 degrees and that one's 43 degrees, that means that the angle inside there is 3 degrees, right? Because the difference between 46 degrees and 43 degrees is 3 degrees. So now I have an opposite side angle pair. I could also pay attention to the fact that this angle right here was 46 degrees, and this angle in total is a 90-degree angle. So that means that if that angle is 46 degrees, the other angle must be 44 degrees. So I can use my knowledge, oops, kind of erased everything there. I can use my knowledge of the fact that this whole thing is 90 degrees to figure out that this part right here, this is 44 degrees. So I'm just going to label this triangle so I know what it is I'm dealing with. I'm going to say this is A, this is B, and let's call this side C. Doesn't really matter how I label it. What I want to do is figure out angle A. I already know angle B and C, so I can figure out A just fine. A is going to be 180 minus 3 degrees minus 44 degrees. So A is 133 degrees. Although I didn't really need A, now that I think about it, because all I really want to figure out is this side right here. I want to figure out what is this side. Because if I know that side right there, that means I can use one of my right angle triangles to figure out the height of the building. So I'm going to use sine law to figure out what x is. So x over the sine of 44 is equal to 10 over the sine of 3. So that means x is going to equal to 10 sine 44. It's the same thing if I multiply sine of 44 times 10 or 10 times sine 44. And it's going to be divided by the sine of 3. So x, plugging this into my calculator, x is 132.7306 meters, right? Because we're dealing with meters in our flagpole, that means that x is being solved in meters. Okay, so now I know the smaller triangle. I know this right angle triangle right here. I know that this part is 43 degrees. I know that the hypotenuse is 132.73 .7306. I'm just going to write 7 meters. And I'm still trying to figure out what the height is. So I can just use, I know that the height over here is the opposite, and I know that my hypotenuse is 132. So what has the opposite and hypotenuse in it? Sine does. So I can say that the sine of 43 degrees is equal to the height of the building divided by 132. And I'm going to keep my 4 decimal places just to be extra accurate. And then I'll round it at the very end of answering this question. So the height of the building is going to equal 132.7306 times sine of 43. So 132.7306 times the sine of 43. The height of the building is 90.5221 meters tall. So if I'm rounding it to 1 decimal place, as the question asks, I'm going to write that final answer as 90.5 meters. And then, of course, since it is a word problem, I have to write my final answer as a sentence. So therefore, the height of the building is 90.5 meters tall. All right, so what did I do in total? I first read the question, I highlighted the important parts, and then I drew a sketch of like one piece of the question at a time. If I just read the whole question, it is a little bit overwhelming. So what I do is I just kind of start drawing by reading one piece of the question at a time to draw an accurate drawing. And then I noticed that I had this angle side pair over here, and I was also able to figure out one of my other angles to figure out what one of the sides of this triangle was. I could have also figured out angle A and solved it by finding the other hypotenuse and using the 46-degree angle triangle. But in this case, I just found the side of the smaller right angle triangle by solving for x here. And then once I had x, well, I knew my hypotenuse. I was looking for an opposite, so I used sine of 43 degrees, and I solved for the height of the It is the height of the triangle, but it's also representing the height of the building in this question. All right. Good luck in solving these kinds of questions in the future.